This video is part 4 of the series on automating the Accu-Slice system. And this is the first prototype we built of the automation system. And it consists of a ball screw, which is attached with plates to both ends of my rail. And it worked quite well. I was quite happy with the results of it. A few issues. Number one, it's kind of big and cumbersome. It's especially cumbersome taking on and off the bandsaw. Since it's attached to this rail, it's a large system. It's cumbersome. It doesn't lay flat on the table when you take it off. And the other issue is this ball screw, since it's unsupported, it gets a lot of vibration as you're running it, and it's a little bit noisy. So I decided to come up with a new design, something a little bit more streamer, maybe lighter weight, and easier to take on and off the bandsaw. So let me take this off the bandsaw and I'll show you the new system we're working on. And this is the problem. How do you hold this thing? You hold it by this and it tilts. You hold it by this ball screw and you could be bending it. So it's not at all easy to take this off and on the bandsaw. The new system is not attached to the rail at all. The rail goes on separately on the bandsaw, like you normally put it on. And this is a new rail. The ball screw, very similar to the last one, but the ball screw mechanism, or saddle, or whatever you might call it, that rides on the ball screw, actually rides on this linear rail. Since it's supported on this linear rail, you don't get that vibration in the system that we got in the previous system. And it's all contained, so it's not attached to the rail. It's balanced. I can take it off and on the bandsaw much easier. It gets attached to the table with some clamps. I made 2 clamps here and here that actually just clamp on the edges of my Accu-Slice table. So these clamps just slide on underneath and they get clamped in place. The other advantage of the system, it has this rail, and on the sides of the rail are these slots with some screws in it. And I actually mount my sensor, my end sensor, and it can slide in place. This is the Hall sensor. I change it from my contact switches to these Hall sensors. And I have one on the end here. I have another one, the order hasn't arrived yet for the other end. But basically when I have a board on here, maybe I'm only cutting a board maybe 12 inches long, I can move my sensors in and have my automatic stops wherever I want them. And it can be adjusted, and this cord can just rest in that slot to keep it out of the way. So I said this mounts to the bandsaw table with these 2 clamps, and I usually create a spacer here to keep it parallel. So in this case I have a bar of metal just 1.5 inches wide. Put it in there, push it against there, and then just tighten these screws on the bottom. Right now they're set screws, but I'm going to replace those with thumb screws and just attach both ends. And that's all there is. Now, as I mentioned, this screw system not only rides on the ball screw, but also rides on this linear rail. So you don't get that vibration. It runs nice and smooth and even, which I'll show in a minute. I made a few other changes to the system. I did redo the software to create a digital readout. So this reads out the actual speed in inches per minute that I'm traveling down the rail. And I did make some connectors here to disconnect and connect the stepper motor without having to move the whole assembly when you're transferring it. Just unscrews. So the same as before, I have programmed where automatically goes automatically at a set speed with these buttons. You see how much quieter and smoother that runs than the previous system. And I can stop it, and of course then you have your jog left and right also. But you don't get that vibration of this ball screw like we had in the previous system. Now the one thing to note, as this is running, if I change the speed, you hear that jogging? That's the software. The Arduino screw I'm using here only can do one thing at a time, so it's either printing to the display or it's running the stepper motor. So when I'm trying to run the stepper motor, if I change the speed, it's going to give me that jogging step. So I'll try and overcome that in the future with some additional software to redesign. But for now, I really want 2 speeds. When it's going through the bandsaw blade, I'm going to set it for maybe 20 inches per minute. I'm not going to change that speed. But then when I reverse, I want to go quicker. So I'll go, you know, reverse much faster. So let's go ahead and put a board on here and we'll give it a test. So I have a piece of walnut here. It's about 2.5 inches tall by 1.5 inches wide by about 35 inches long. I'll just mount that on my system. Now this ball screw is a special order. The one disadvantage of this system is it is more expensive than the previous system. Actually, it's about 3 times more expensive. And the length is only 1,000 millimeter, which is about 39 inches. So the maximum board length that I can cut on this is 36 inches. For the previous one, I was actually able to cut a board 50 inches long. So it is a little bit shorter, but for my purposes, you know, I don't cut anything usually over 32 inches long, so it works fine. But this board is 35 inches long. It mounts to the rail with a clamp here. And I just have a piece on here that I actually am tapping in one of the holes on the Accu-Sled II plate. And that's all I have to install it. Now what I'll do first of all, I'll take it the whole way down and set my end sensor. So I can jog it down. And set my end sensor. The speed's a little too fast. So I make sure I cut the entire length of the board, which is right about there. So let me go and set my sensor and lock it in place on the rail. Okay, and I can move it back. And then just like normal, adjust my Accu-Slice system. Zero out my index wheel. Push it till the board just touches the bandsaw blade, just like we normally do. Lock it in place and move it back. And I'll do 2 full turns to give me a first rough cut. Guides. Gotta watch, I have this sticking up. Okay, I am using a 1/2 inch wide blade. This is 1/18 per inch, and this is a piece of walnut. And I'll burn this kind of slow, maybe at 15 to 20 inches per minute. Once again, to reduce viewing time, I did speed this section of the video up 5 times the actual operating speed. So let's go and cut on the board 25,000 of an inch thick. And I'm going to cut this at around 10 inches per minute. You can see that Hall sensor sensed the end and stopped it automatically. And we got our board off. Let's measure it, see what we have here. 27.5, 27.5, 28.5, and 27. 27, 27.5, 27.5, and 27.5. This is the hall sensor that I added to the system. Instead of using the switches with a lever arm, this is a hall sensor, so it senses a magnet. And I have a magnet attached to the carriage. So when a magnet comes near here, you see the light goes on, and that actually turns a switch, which will stop the system. So that's how that works. So I have one installed on the tail end. I have another one will be installed on the top end. And I said this can be adjusted. Again, I have thumb screws in order that haven't come in yet, but that can be adjusted anywhere on this rail, which makes it real nice for setting up your system and having an automatic stop. Let me tilt this up a little bit so you can see a little bit clearer. Just getting a reflection of the lights. But as I'm going, let's take this back. So right now it's going at minus 10 inches per minute. And as I increase the speed, here's 12, 15, 18, 22, 30. 40 inches per minute. And there was the 10 inches per minute that I ran the board through. What I'm probably going to do is set up a program in the future that, it goes through at the normal speed, but it reverses automatically at a higher speed. So that's just a programming thing to do in the future. Let's show this from a different angle. Let me cut another piece, and let me try and cut a piece. Let's try, see if we can do 10 thousandths. That's 10 thousandths of an inch. And I'm going to run this through at 10 inch. Well, let me slow it down to maybe like 8 inches per minute. Slow it down a little bit more even. So it cuts fine at slow speeds, but what about cutting at a higher speed? Maybe you want to cut stuff faster, and you can live with more saw blade marks on your wood. So let's first of all reverse this. So let's cut this at say 30 inches per minute. So let's cut another board 25,000 of an inch thick. Cut this at 30 inches per minute. In fact, here's the two boards. Here's the top board here is 10 inches per minute, and the bottom one is the 30 inches per minute. So in the next video, I'll be showing the automating the indexing wheel, which is probably going to be more useful to people that can automatically index. Because one of the questions we got a lot of time is, well, I want to use metric, or I want to use fractions. I don't want to use the decimal like we normally use in our system. But when it's computer driven, you can make those numbers whatever you want. So I have the software actually done already. I spent the last week designing the software, so the software console is already made and done. And now I'm working on at least 2, maybe 3 designs for the index wheel. My first thought is to use the existing indexer. My concern is the teeth. It's a very, very fine thread, and it's not really designed for like this ball screw. It's actually designed for linear smooth travel. This is just a 20 thread per inch screw in here, so it may not be as smooth as this might be, but it's 20 threads per inches, where this is 5 or 6 threads per inch. So I got more threads per inch. It may, I don't know, maybe better, maybe worse, I don't know. But I have the system actually built for this already. I'll be testing that next. And then I have some systems using a ball screw which I'll be making in the future also. So that'll be the next video, is automating the index wheel. So this is meant to be a short video, just keeping you updated on the status of what we've been doing to automate the system. I've been spending actually almost 4 weeks now working on this and continuing to make improvements to the system. And I just want to keep you informed of what steps that are going on. And I'll continue to make improvements. You know, this display system works nice, but as it trying to run two things at once, it causes the stepper motors to jog a little bit. So I have to see if I can get around that problem. Also, I can set up programs to automatically run the system at set programs, which is what I've done in the indexing wheel. It automatically runs at a set program, which you program into the system before you start. But we'll continue to redesigning the console here, so the display is actually in the console. I'll be working on it also. This concludes this video on the automation of the Accu-Slice system. If you have any questions or concerns or comments or ideas for me to improve the system, I'd like to hear from you. So please drop us a line or send us an email with your ideas. Always looking for ways to improve the system. And I'll continue to make changes and improvements to the system as I go along. Adding another Hall sensor, putting some thumb screws on here, redoing the electronics console. These are all things that will be updated in the future. But the next video, I said, will be on the indexing system, which I'm working on right now. So once again, thank you for watching this video.